Hi, welcome to the screencast for milestone 3 of the DevOps project. So this is the deployment milestone. So in a deployment milestone, what we have done is that we have extended the green-blue deployment strategy which we had learned in the workshop. So in the first task, what I'll be showing you is that we will configure a production environment automatically. So I will run a few scripts which will automatically create all our infrastructure components such as web server, the app server, the load balancer, and the Redis store. And then we'll use Ansible, which is a configuration management tool, to install all the necessary softwares. And these two steps will create the entire cluster which is required for our infrastructure. So the first thing I'll do is I'll run a script which will create the droplets which are required on DigitalOcean. So I'll just run that. So this is my DigitalOcean. So you'll see that so there are 4 servers which are getting initialized here. The first one is the app server, where our actual web application will be deployed. The second one is a canary server, so I'll come to this a bit later on. The third one is the proxy server, which also acts as the load balancer. So currently what happens is that all the requests which are made to the proxy server are directed to the app server. We'll see how the proxy server comes into play when we show auto scaling. And the fourth one is the global Redis store, which stores the information about the servers, about the feature flags, etc. So you can see that all 4 droplets have been created. So now only the droplets have been created. We also need to install the softwares on these droplets. So for that I've used Ansible. So I'll just run the Ansible playbook now. So you can see here that the inventory file has been created with all the necessary servers. Also, you will see that there's an additional Jenkins server which is added to this, which we have already created beforehand. So now I'll run the playbook which will install all the softwares. So the command for that is Ansible playbook. Provision playbook -i inventory. So now the Ansible playbook is installing the list of softwares over here. So I'll just show you the playbook. You can see that in the Redis server I'm installing all these roles. In the app server I'm installing all of these, and so on. So each one of them will get configured with the required list of softwares. So we can see that is running. So this will take around 10 minutes to run. So I'll just pause the video, and then once it's complete we can get back to this. Hi, so the configuration management step has been completed, as you can see, and we have created 4 servers on DigitalOcean using Ansible. So this is the completion of task 1. So for the next task, we are required to deploy the software in the production environment. So before deploying the software, we have to run the build, testing, and analysis stage. Like we did in the previous pipeline, we will do this after making using a post commit. So in my testing and analysis stage, I'm checking for 2 things. One is that I should not have any issues with severity with any errors after running gsint, and also the branch coverage should be at the threshold of at least 80%. So temporarily I'll just increase this to 100% to show you that my build is failing. So I'll make a change over here. and I'll commit this change. And you can see that we cannot proceed since the branch coverage is less than 100%. So I'll just revert this back to the previous threshold. And now you can see that the build has been triggered successfully. So show you here that the build gets triggered on my local Jenkins machine. So we'll wait for the build to complete, and once the build is complete, then we can deploy the software. I'll just pause the video till the build completes. So as you can see that my build has completed, so I can then push the code. So some change made, I'll just okay. So using a webhook, my deployment will happen again using Jenkins. So I've created another Jenkins server here. So you can see over here I am doing the deployment using a Ansible playbook. So the deployment is happening on the remote droplet, on the app server droplet over here. So we'll wait for the build to complete again, and then we'll check the app server once the build has been completed. So now you can see that the application has been successfully deployed on the remote droplet. So I'll just check this using the app server. So if I go on 3000 ports, you can see that the application is now running. And I can also show you the proxy server. So right now, since there is only one server, all requests to the proxy server are redirected to this one over here. I'll just show you that. In my Redis, you can see that this has been added. The IP address has been added over here. And if in my proxy server, I can show you the logs. Where you can see that all the proxy requests are redirected to the same server. And also you can see on the app server that my application has been deployed over here after making the change. So this task has been completed. For my next task, I have to monitor the deployed application using at least two metrics. So the two metrics which we have chosen are CPU utilization and memory utilization. And whenever these go above a certain threshold, we will be sending an SMS using the Twilio API. So I'll use the stress command to increase the CPU utilization on my app server. So my app server is here, so this command. So I'll just wait for some time to get the SMS. So yeah, so I have the SMS right now. So I'll show you, I'll attach a screenshot of the SMS along with the README. So this is for the monitoring. I can show you the script to which we are using for monitoring. Here you can see that it's monitoring the PSUtil CPU percent and the virtual memory. So the auto scaling one I'll show you next a little later on. Now I'll show you the feature flags. So using feature flags are like toggle functionality of a certain feature. So the feature for which I'll be toggling functionality is the remove the remove an is to remove an element from the set. So I have this application developed to set or disable the feature flags. So this is running here. So what I'll do first is I'll create the feature. So to create the feature, so this feature is created and it is enabled by default. So when I'll create a set also over here, which is a test set. Sorry about that. So the test set is created. And I'll add a few values to the set. So you can see the set. Now when I try to remove a certain value from the test, I will see that since the feature was enabled by default, I am able to remove the values. So now I'll go here and I will disable the feature. So the feature can be disabled by using the toggle command here. So now the feature has been disabled, and now when I try to remove something, you can see that the remove set feature is currently disabled. So if I try and remove any element, I'm not able to remove it. Now if I want to set the feature again, I go here and enable it again, and subsequently you can see that it has been removed. So this is how feature flags is working. So all this is happening by using a global Redis store, where the Redis store is actually storing the value of the feature flag, and depending upon the value which is retrieved from the global Redis store, we are exposing the functionality to the user or hiding it. So the next part of our milestone was to implement a canary release, and once we do the canary release using the proxy server, we'll be routing traffic alternatively to this canary server, which has a new feature and our original software. So I have a canary branch over here where I will make my new changes. So I'll just check out the canary branch, and I'll make a small change over here to canary. So I'll add this canary, and this triggers my build on the local machine. So I'll just wait for this spell to get over, and once the spell gets over, then I can proceed with the push command. So you can see that the build has been completed, so I will push to the canary branch. And in my Jenkins server, I have another job created which will help me deploy the canary, deploy the application on the canary server. So again, I'm doing this using Ansible. So right now you can see that nothing is running on my canary server, nor is any traffic getting routed here from the proxy server, since it is not added to the list of servers in the Redis store. So let's just wait for this to get completed. So this has been completed. So now if I go to that address, you can see that my canary application has been deployed here. And if I use my proxy server, the proxy server will now alternate traffic between these two. So you can see it's in the master, canary, master, and canary. So it is alternating traffic here, and you can also see in the Redis store is maintaining my list of servers which are currently active. So if for some reason there is any exception in the canary server, it will automatically get removed from this list over here. So if it gets removed from this list, the proxy server will automatically stop routing it through that. So you can see over here, alternatively you can see the route changing depending upon the request. So that was about the canary release. So for the last step, I'll be demonstrating the auto scaling of the individual components. So we are auto scaling defined depending on a predefined rule of number of incoming requests to the proxy server. So if the number of incoming requests to a proxy server exceeds a certain amount, then we will be scaling and creating a new server where the application will be deployed. Also, we will maintain a track of the servers which are created in the Redis store so that the proxy server can alternate between the available servers. So I'll just start my script to auto scale, and now it is auto scaling, and I'll just run a few commands here to trigger the auto scaling. So let's just wait for that. So you can see that the auto scaling has been triggered and a new droplet will get created over here. So once it gets created, the Ansible playbook will run on this to deploy the application. So when that happens, I'll just so my auto scaled application has been successfully deployed. So in my Redis server, you can see that it is being added to the list of servers here. So when I go on 8081, it will alternatively deploy between the 3 servers which I have now, which are 2 with the master branch and 1 with the canary. So here when I go and see the log, you can see that the requests are being alternated between the three servers. So now I'll show you the scaling down. The scaling down part. So I'll just start my application again and shut it down to stop the auto scaling since it wasn't required earlier. So I'll start it again. So you can see since the requests aren't come, since there aren't a lot of requests, it straight away went here and deleted the droplet. So you can see that the droplet got deleted. Again, the logic for this is that if I have more than 5 requests, then I scale up, else in a certain amount, if I don't get the number of those requests, I scale down. And in scale down, what I do is that I've tagged all the servers which are scaled up. So I retrieve, I get the scale droplets and then I just delete one of them, and I also remove it from the list of servers. So now if I go in my proxy, I'll see that it's being alternated between just 2 of them. So you can see that it has been successfully scaled now. That's it. Thank you.